All right, guys, welcome back from break. These are going to be your notes for 11.1. It's solving linear systems by graphing. Zoom in. I have a couple vocab things to go over with you. A system of linear equations consists of two or more equations that have the same variables. And a solution of a system is any ordered pair that satisfies both or all equations. Okay? So there are different ways to find solutions to systems. Obviously, we're going to start by graphing. The first thing you have to do is put them in slope-intercept form. So this would be a system here. So you're going to rewrite and put them both in slope-intercept form. You'll graph the lines and look for their point of intersection. The point of intersection is the solution. So on this first example, they cross at 2, -2. So that would be the solution to these two lines. If the lines have the same slope but different y-intercepts, they won't intersect, and that's an example of no solution. And if the graphs are the same line, then there are an infinite number of solutions. Okay, so we're going to look at number 1 and 2 on this front side here. Now, it's a little hard when we do the graphing. It's a little hard to see, but so our first equation, we need to solve for y, so that would be y equals -x minus 1. And the second one, put x on the other side. We have -2y equals -4x minus 16. And then we divide everything by -2. So we end up with y equals 2x plus 8. Okay, we're going to go ahead and graph both lines. If you like to graph in different colors so you can see, that's okay. You don't have to. So the first one starts at -1, and it's -x. So, and you want to make your lines go all the way across the coordinate plane. So if I go down 1 and right 1, make some guidelines, and up 1, left 1. We'll go ahead and make our line. The reason you want to make it go all the way across is you're not exactly sure where they're going to hit each other at. The second line has to start at 8. This only goes to 7, so 8 would be up here. And the slope is 2, so I can go down 2, left 1. And you should, and obviously I've already found it, but get to a point where the two lines cross each other. At my point of intersection is going to be the solution to that system, and that point is -3, 2. You can always check by putting these numbers back in both equations, and I would do the y equals 1 and see if you get the right answer. You should get an equal answer. Okay, for number 2, I need to add 3x to both sides of the first one. So that's y equals 3x plus 10. And for the second one, the first thing I'm going to do is add 2x. So I have 4y equals 2x, and then divide by 4, so y equals 1/2 x. Okay, the first one is 10, so again that would be 3 above, so I'm going to go down 3 and left 1, and that'll put my first mark there, and then down 3, left 1, 2, 3, Again, bringing the graph all the way through the coordinate plane. Okay. It is very important also when you're graphing a system that you're using either a ruler or a piece of paper, something with a straight edge, because you can't have wobbly lines and figure out where they cross each other. My second equation, the y-intercept is 0, and it's 1/2, and I need to go to the left, so I'm going to go down 1, left 2. Okay. Okay. And again, the point of intersection where they cross is my solution. So the solution to this system is -4, -2. All right. Going to turn to the extra notes side. We have just 3 more. Okay, the first example can be found on page 390 in your book. It's your turn number 5. Okay, and these are the 2 equations they give us. Y equals -x minus 2 and x plus y plus 2 equals 0. So I need to solve this second equation for y. So I'm going to subtract x and subtract 2. So y equals -x minus 2. So my first one, I'm going to start at -2. And it's -1 slope, so I'm going to go down 1, right 1, up and left, and make my line. Okay, and our second equation is the same as the first one. So to symbolize that I have graphed both and I know that they're the same line, I'm just going to add a second set of arrows to it. So you're symbolizing that, yes, you did graph both and they are on top of each other. So when you have the same slope, same y-intercept, this is an example of infinitely many solutions. Infinitely many solutions. Okay, the next example I have for you is also on page 390. It's your turn number 6. And again, the first equation is already in slope-intercept form, so we're going to solve the second one by adding 2/3 x to both sides. So this becomes y equals 2/3 x plus 1. So we're going to go ahead and graph the first equation. I'm going to start at -1, and it's positive 2/3, so up to right 3, and down to left 3. And then my second line starts at +1, and the slope is 2/3, so up to right 3, down to left 3. Okay, and you can see these are forming parallel lines. Kind of got my other graph in the way a little bit. Okay, so those are parallel lines and they're never going to touch each other. So this is an example of no solution. Okay. And then one more example. It's a story problem. It's on page 391. It is your turn number 10. It says a video club charges $10 for membership and $4 per movie rental. Video Club B charges $15 for membership and $3 per movie rental. For how many rentals will the cost be the same at both video clubs? What is that cost? So write a system and solve by graphing. So we need to write an equation for A and then an equation for B. So our equation for A is going to be y equals 4x plus 10. And our equation for B, y equals 3x plus 15. Okay, and systems have the bracket around them, or brace, I guess, to symbolize that they go together. They are a system. Okay, the way we wrote these, they're both solved for y already, so we can go ahead and graph them. I went ahead and broke my graph and started at 10 and went up by 2s. And then on the bottom I went by 1s. When you're making your graphs for the story problems on your homework, make sure that you remember to label your axes. Okay? So we're going to start at 10, and it's a slope of 4, so I go up 4, right 1. Again, you want to make as many points as possible. Right, my other one starts at 15 and goes by 3. So 18, 1, 21, 2, 24, 3, 27, 4, and 35, 33, 6. Okay. And this one's a good example of making sure that we have neat lines, because they come very close to crossing here, but they don't quite. So the point of intersection is 530. The story problem asked us, however, for how many movie rentals will the cost be the same, and what's the cost? So the ordered pair 530 it's going to be 5 movies, and the cost is $30. So make sure that you label your answers for your homework as well. The homework that goes with this lesson, 11.1, is on page 392 to 393. It's numbers 1 through 12, no, 2 through 12, even. And then number 18 and 22.